Right now, under the hood of almost every Cummins-powered Dodge Ram built between 1994 and 1998, there is an injection pump that can support 700 rear-wheel horsepower. From the factory, it makes about 160. That is not a typo. The Bosch P7100 injection pump, bolted to the side of the 12-valve 5.9-liter Cummins, is one of the most over-engineered, deliberately handicapped pieces of hardware Detroit has ever produced. And the best part? The tools you need to wake it up are already in your garage. This is not a parts list. This is not a sales pitch. These are 5 mechanical tricks, hidden inside the pump, the turbo, and the computer that the factory locked down on purpose. Some of them cost nothing. Some of them cost $15. And one of them involves lying to your own truck's brain. Number 5. The fuel plate. Open up the air-fuel control housing on a P7100 and you will find a small, contoured piece of metal sitting between the governor arm and the fuel rack. That is the fuel plate. Its job is simple. It physically limits how far the fuel rack can travel. Less rack travel means less fuel. Less fuel means less power. Dodge put it there because they had to. The fuel plate is a compliance part. It keeps the engine at a certified power level for emissions, noise, and warranty purposes. The engine does not need it to run. The engine does not need it to be reliable. The engine needs it to be legal. Here is the part that makes diesel guys angry. Different fuel plates have different contour profiles. The 160 horsepower truck and the 215 horsepower truck both use the same P7100 pump. The difference? A different shaped piece of metal limiting how far the rack can travel. Your 160 horsepower truck is not a weaker engine. It is the same engine with a smaller leash. Remove the plate entirely, and you get full rack travel. That means more fuel reaches the plungers, more fuel reaches the injectors, and the engine starts making noticeably more power. How much depends on the rest of your fueling setup, but removing the plate is the first domino. Without it, none of the other P-Pump mods reach their full potential. Cost to do this? $0. Time? About 30 minutes with basic hand tools. The AFC housing comes off with a tamper-resistant bolt, not tamper-proof, just resistant, and 2 mounting bolts underneath. But here's the thing nobody tells you. Running full rack travel without addressing airflow is a bad idea. You will make more fuel than the turbo can match, your exhaust gas temperatures will climb past 1200 degrees, and you will be blowing black smoke that is not power. It is waste. Every molecule of diesel that does not burn completely is wasted energy and wasted money. The fuel plate is step 1. Not the only step. The guys who pull the plate and stop there are the guys blowing smoke at the truck meet and wondering why they are not making the power they expected. Number 4. The AFC housing slide. The air-fuel control assembly sits on the back of the P7100. It controls how much fuel the pump delivers at low boost. From the factory, it is set conservatively. Way conservatively. The AFC is the reason your 12-valve feels sluggish off idle and only starts pulling hard once the turbo spools. There are 3 adjustments hidden inside this one housing, and combined, they are worth up to 60 horsepower and 200 foot-pounds of torque for free. First, slide the entire AFC housing forward toward the front of the pump. This changes the governor linkage geometry and opens the fuel rack earlier in the RPM range. It brings fueling in at lower boost levels, which means your engine stops waiting around for the turbo to wake up. Second, the star wheel. It is inside the AFC housing, accessible through a plug on top. Use a flathead screwdriver and rotate it toward the passenger side of the truck. This opens the fuel rack further. Small adjustments. A quarter turn at a time, then drive it, then adjust again. Third, the pre-boost screw. It is on the backside of the AFC housing. Backing it out changes the pump's governor linkage and adjusts the rack forward, bringing significantly more off-idle fueling into the equation. Combine all 3 full forward housing, turned star wheel, adjusted pre-boost screw, and you are looking at gains that guys on the Cummins forums have documented for over 20 years. 60 horsepower, 200 foot-pounds. The tools are a flathead screwdriver and a basic set of Allen wrenches. The factory knew exactly what this housing could do. They set it to the tamest position possible and hoped you would never look inside. Number 3. The Mack rack plug. This one costs $10 to $15. It is a small metal plug originally designed for Mack truck injection pumps. When installed in a P7100, it increases fuel rack travel to a full 21 millimeters. Stock plugs limit travel to somewhere between 18 and 19 millimeters depending on the pump model. That does not sound like much, but those extra millimeters of rack travel send roughly 70 cubic centimeters more fuel into the pump's plungers. On the right setup, that is worth up to 35 additional horsepower from a part you can hold between 2 fingers. The install requires pulling the front gear housing cover and doing a small amount of clearancing. It is not difficult. It is not dangerous. It is just something Dodge never wanted you to know existed. Here is why this matters. The P7100 was used across multiple platforms: Dodge trucks, agricultural equipment, industrial applications. Different markets got different rack plugs with different travel limits. The Mack plug simply gives you the travel that heavier-duty applications were already using. Your engine can handle it. Bosch designed it to handle it. Dodge just chose to restrict it. $10 to $15. A Saturday afternoon. Up to 35 horsepower. One thing to know, if you have a 215 horsepower pump, that is the 96 to 98 manual transmission trucks, the Mack plug is generally not recommended. At 21 millimeters of rack travel, the retarding barrels in the 215 pump can pull timing back up to 3 degrees, which works against you. On the 160, 175, and 180 pumps, it is a straight upgrade. Number 2. The governor spring. This is the one that changes everything. From the factory, the P7100 on a 12-valve Cummins governs engine speed to approximately 2,700 RPM, but the actual defueling starts earlier, around 2,400. That means your engine begins cutting fuel before it even hits the stock red line. Think about what that means. You do all the free mods. You pull the fuel plate, you slide the AFC forward, you turn the star wheel, you install the Mack plug. Your pump is now delivering significantly more fuel. But you can only use it in a tiny RPM window because the governor spring is slamming the door shut at 2,400. A $35 to $50 governor spring kit changes the defuel point to 3,000 RPM. Some kits go to 4,000. Competition setups from companies like Shai Diesel and Columbus Diesel Supply go all the way to 7,000. The engine's power band opens up like someone just unchained it. To put this in perspective, the guys making 500, 600, even 700 rear-wheel horsepower on P-pumped 12 valves are all running modified governor springs. Every single one. You cannot make big power on this platform without extending the RPM range first. The governor spring is the gatekeeper, always has been. The reason this is number 2 and not number 1 is because the governor spring is what unlocks everything else. Without it, all those fueling mods are fighting in a phone booth. With it, they can actually breathe. The fuel plate removal, the AFC mods, the Mack plug, all of those gains are multiplied once the engine can actually rev into the range where those modifications produce their peak numbers. One word of caution: if you plan to spin a 12-valve past 3,500 RPM, you need stiffer valve springs in the head. The factory valve springs are not designed for sustained high RPM operation. This is not optional. This is protecting your engine, but at 3,000 RPM, with a $50 spring kit that is safe, documented, and proven across thousands of trucks over 25 years. It is the single most impactful modification per dollar on any diesel platform ever built. Number 1. The Boost Foaler. This one is different. This is not a P7100 trick. This applies to the common rail Cummins trucks. 1998.5 and newer. And it is the most brazen example of a factory leaving power on the table. Every common rail Cummins has a MAP sensor in the intake manifold. MAP stands for Manifold Absolute Pressure. It reads boost. The ECM, the engine control module, the truck's brain, monitors that signal constantly. When the MAP sensor reports boost pressure exceeding approximately 20 to 21 psi, the ECM defuels the engine. It actively pulls fuel out of the injection cycle to prevent boost from climbing any higher. On high-output trucks, the threshold is slightly higher, but the principle is identical. Here's the problem. The turbocharger on your truck is physically capable of producing 30, 35, even 40 psi of boost. The air is right there. The turbo is already compressing it. But the ECM reads the MAP signal, sees 21 psi, panics, and cuts fuel. Your truck's own computer is a snitch. A boost fooler intercepts the MAP sensor signal before it reaches the ECM. It caps the voltage at the equivalent of 19 to 20 psi. The ECM thinks everything is normal. It keeps feeding fuel. The turbo keeps compressing air, and you start making real power. And this is not just a Cummins thing. Power stroke owners have the same problem. On 99 and newer 7.3-liter trucks, the PCM defuels at about 24 psi. Same principle. Same fix. The ITP Overboost Annihilator has been solving this on Power Strokes for over 15 years. Different brand, same factory paranoia. But the boost fooler alone is only half the equation. And this is where most people get stuck. Even with the ECM fooled, your turbo has a mechanical wastegate. On HX35 and HY35 turbochargers, the wastegate opens at approximately 20 psi and physically bleeds off exhaust pressure to prevent the turbo from spinning faster. So you need a boost elbow on the HX35 or a J-hook on the HY35. The boost elbow replaces the stock fitting coming out of the compressor housing with one that has a smaller orifice, restricting the air signal that tells the wastegate to open. The J-hook does the same thing on the HY35 with a spring-loaded mechanism. The result? You have fooled the computer. You have fooled the turbo. And now both of them are doing what they were physically capable of doing all along, just making power. With a boost fooler and a controlled wastegate, guys are running 30-35 psi on stock turbochargers. Combined with the P-pump mods we already talked about, you are looking at more than double the stock power output. Driving Line has documented over 100 horsepower from the free mods alone, before you even touch the turbo side of the equation. One important thing: stock head gaskets and head bolts can typically handle 35 to 40 psi. Beyond that, you need ARP studs. Do not skip this. Boost is pressure. Pressure lifts heads. Lifted heads ruin engines. 5 tricks: a flathead screwdriver, a set of Allen wrenches, $15 in parts for the rack plug, $50 for the governor spring, and the willingness to lie to a computer. Everything we just talked about was already built into your truck. The fuel capacity was there. The airflow was there. The mechanical strength was there. Dodge, Cummins, and Bosch just decided you did not need to know about it. 25 years later, the 12-valve Cummins with a P7100 is worth more than it sold for new. Not because of what it was from the factory, because of what people figured out it could be once they opened it up and started looking. The irony is that emissions regulations created the legend. The EPA killed the mechanical injection pump after 1998. Common rail took over. Computers took over. And suddenly, the truck that had no electronics, no emissions equipment worth mentioning, and a fuel system you could modify with hand tools became the most sought-after diesel platform in America. They tried to bury this engine. They made it more valuable instead.